up, everyone? Welcome back to Concrete Talk, where we talk about concrete. But let's make it interesting. Today, we will talk about did you know? So our topic today is about this two person named Nelson Durai, and Kudasami. Sorry if I butchered the name. They three did the impossible.
Oh yeah, I read that. They are from Valentine in China, right? They basically try to make concrete using waste material instead of normal cement and aggregates.
Oh wait, what? Waste material? Like, isn't it that supposed to make a concrete vehicle?
Yeah, that's the crazy part. They replace cement, sand, and cost aggregate at all once. And their sustainability makes steel come out stronger than conventional concrete. That's why today we're breaking down about their research, how they did it, why they use it, and why it's better.
Exactly. Let's get into the background first. Why they even tried this in the first place? Okay, so quick background. Concrete is everywhere. Building, roads, bridge, but problem is cement. Cement production creates huge environment impact and contribute about 8% of global CO2 emission, which is massive. And it's not only cement. Natural sand and aggregates are being overmined to meet construction demand, which is damage the ecosystem and increase the cost over time. So they basically ask a big question: can we make concrete more sustainable by replacing cement, fine aggregate, and coarse aggregate with waste recycled material, without losing the strength of it? So their objective is to reduce carbon footprint, reduce landfill waste, save natural resource, and still keep aggregate strong enough to real construction. Alright, so let's start with person 2 or Afif.
Okay.
What did they do?
Okay. So the replacement are split into three groups. First, cement replacement. They use supplementary common cementitious materials, which are industrial byproducts that can behave like cement. Example, they use GGBFS, that means ground granulate plus furnace slag, metakaolin, and alkofine. This reduce cement demand and improve bonding inside concrete. Second, fine aggregate replacement. Basically sand. They replace river sand with cocoa slag and foundry sand. Both are industrial waste, so it's a double benefit. Less sand mining and less landfill waste. Third, coarse aggregate replacement. They use sintered fly ash aggregates and recycled aggregates from construction waste. So instead of fresh crushed stone, they reuse existing materials. They test many combinations to find the best sustainable one. After all trials, the optimal mix they chose is called CFACA 1, 2, 3, 4, 5, 6, 7. The replacement proportions were cement replaced by 50% alkofine, 10% metakaolin, plus 30% GGBFS. Fine aggregate replaced by 50% cocoa slag, 30% foundry sand. Coarse aggregate replaced by 20% recycled aggregates, 30% sintered fly ash aggregate. This mix gave the best balance of sustainability and mechanical performance.
CFCA 1, 2, 3, 4, 5, 6, 7. That sounds like a password, but okay. Now, person 3 or Amir, how did they test it if it actually worked?
Right, so they follow standard concrete testing but apply it to this new mixer. Dig concrete samples and cure them for 7, 40 and 28 days. Two main strength tests were done: compressive strength test, split test, strength tests. They also test raw material for physical properties like grading and specific gravity, just to make sure everything is sustainable or missing. So overall, the experiment is far sustainable with misses and normal concrete tests under the same standard.
Cool. So now the important part. Did the sustainable concrete win? Kacau. Yes.
Okay, the results were actually impressive. The optimal sustainable CFA CA 1234567 performed the best compared to conventional concrete. Compressive strength increased by days. Split tensile strength also improved slightly. So even though they replaced a lot of original material, the concrete didn't weaken, it got stronger. That's likely because the cement replacement improved. Microfilling and bonding, and the waste aggregate still carry load effectively.
So, this is proof that sustainable doesn't mean low quality.
Exactly, it shows waste material can work structurally, not just as filler. Now, sustainability-wise, the benefits come in three clear layers: lower CO2 emission, 2. Industrial waste utilization, 3. Natural resource conservation. So this makes support circular economy. Construction waste become as resource. In real use, this concrete is practically, especially in regions where industrial waste is available locally. Since strength meet or exceed normal concrete, it can be used for structural element, not just sidewalk or block. It could reduce cost too, because these materials are often cheaper than fresh cement and sand. So personally, Amir,
And it is solved two problems and once waste disposal and sustainable use.
Yeah, so it's not just lab theory, it's just game.
to conclude, RA0150 proof that simultaneous replacement of cement fine aggregate and coarse aggregate is possible without reducing strength. The optimal mix achieve better mechanical properties while lowering environmental impact and reducing construction waste. For future work, the next step would be long-term durability studies and larger scale project. But overall, the study strongly support sustainable concrete as a realistic alternative. Okay.
So yeah, episode takeaway. Trash concrete isn't trash, it's a concrete.
Imagine the building will recycle and stronger.
Concrete will blow up.
Alright, that's it from us. Thank you for watching.
Catch us next time. Peace.
Aku ada. Register ni gila.